Next problem. So find the positive integer n is less than 1000, where n squared plus 1 is a multiple of 2029, which is a prime. So I'll just go straight into the main insight here. So a lot of people bash this, and a lot of people actually got it correct. So I'll show why soon. So 2029 is equal to. So the main insight here is that this is a sum of two squares. Now I've seen a lot of solutions here, so I'll just show one of them. So we need like n squared plus 1, which is also a square, to be congruent to 45 squared plus 2 squared modulo 2029. And what you can do is if you multiply it, so this is 0, so you can multiply this by 2 squared, both sides, and 2 squared is 4, which is obviously co-prime with this number, so we can get 2n squared plus 2 squared is still 0, or 45 squared plus 2 squared. And what you can do is that you can cancel out these 2's. 2 squared pala, you just cross them off, and then you get that you get 2n is congruent to positive or negative 45. But this is not odd, so we can like add 2029 to this. So if you calculate that, you should get that 2n is congruent to either 1984 or 2074. Yes, okay. And then which means we can divide by 2 finally to get 992 or 1037. But since we want less than 1000, and indeed in the rules the answers to these problems must be less than 1000 and positive integers, but I assume the problem maker put this here just so that people won't complain about, oh, there's multiple answers, but even though in the instructions they should be less than 1000. So it's 992, and it should be clear how a lot of people bash this. They started from 999 and went downwards. So yeah, there you go. So it's a really smart way. So another way, which is the official solution, is that you can, so if you start from 45 squared plus 2 squared, you can also multiply it with sum of two squares to get, so this is kind of known, so this you can get a sum of two squares back. So just research on this if you guys want. So this should be it, and then you equate one of these to be 1. So you can set this to be 1, and you get that this is 1, that's 22, and it will get that this is 992. So that's how that's another way you can get 992. But this is also works as fine. And in general, actually, if you have n squared plus 1 to be congruent to 0 modulo sum of two squares, actually which is a prime also, and actually it's only possible if a prime can be expressible to this by Fermat. So n is equal to negative a over b. So, and then this division thing, you search up modular inverses. So yeah, this is a general thing how to solve these problems. So